I messed up. I have to take a break. Oh, hi.
I just started. Okay, this is example 4. We are going to start recording example 4 for section 3.2. Y equals x to the 4/5 fails to be differentiable at x equals to 0. Tell whether the problem is a corner, a cusp, a vertical tangent, or a type of discontinuity. So we are going to prove it using our limits. Okay, let's start with the right hand derivative. So this is going to be the problem for this equation. The problem is when x is equal to 0, because the reason I know that the problem of when x equals to 0 is because there is no translation. There's no translation to the right or the left. Okay, so with this you can use derivative at a point, or you can use formal definition of the derivative. We will use derivative at a point, so we'll start with the right. So this is x plus f of x by definition minus f of 0 all over x minus 0. So continue with this definition, limits as x approaches 0 from the right. F of x is x to the 4/5, okay? Minus f of 0 is still 0 all over x minus 0. As you can see, the zeros can be dropped. So x approaches 0 from the right is now x to the 4/5 divided by x. X has an exponent of 1, which is now, I can convert that to 5 over 5, which, because x's are the same, that's the same base, that means I can reduce by subtracting the powers. So if I do that, it's going to be x to the 1/5 now on the bottom. As you can see, you can't really substitute in 0, but you can substitute in something positive coming from the right, like 0.00001, okay? Now, some of you can see this a little bit easier if I were to write this as a radical format. So 1 over 5th root of x. So as x is approaching from the right, that means, again, I'm going to pick 0.0001. So 1 divided by 0.0001, something super positive small, that is going to give me a positive infinity. I'm going to do the same thing to the left-hand derivative, except that I don't need to do all the basic math again. I'm just going to jump all the way to the very end here. Limit as x approaches 0 from the left of 1 over 5th root of x, okay? So now I'm going to be picking or choosing a negative 0.0001. What's happening is 1 divided by a small, tiny negative number is going to be a negative infinity. Because one side is a negative and one side is positive, based on your definition, out of the 4 definitions of non-differentiable, this is a cause for a cusp. Okay, so there is a cusp at x equals to 0, because one side is a positive infinity and one side is a negative infinity. Okay, we're going to do a summary, and then this is the end of our video notes. Summary of the culprits. Okay, 1, you're going to have a corner if you have 2 different slopes. You're going to have a cusp. Oops, that's CUSP. If your limit is negative infinity on one side and positive infinity on the other side. You're going to have a vertical tangent if you have the same infinity on both sides. So whether they're both negative or positive. And then lastly, discontinuity. Okay, so any type of discontinuity will make it non-differentiable. Okay, you can have differentiability on one or both sides. Okay, So one or both sides, discontinuity the derivative of one or both sides does not need to exist or does not exist. One or both sides limits does not exist. Okay, so as long as one side doesn't exist or both sides derivatives don't exist, then that means it's a type of discontinuity. Okay, so here's the end of the culprits, and this is the end of our video notes for today.